Hi students, welcome to day 2 of solving trig equations. Our goal today is to use algebra techniques to solve trig equations, solve using solve equations that are quadratic, solve trig equations involving multiple angle. This is different. Use inverse trig functions to solve trig equations. Okay, let's talk about multiple angle functions. This is called a multiple angle, where you're multiplying your angle, in this case by 2. We're going to pretend for just a moment that it's the sine of x equals the square root of 2 over 2. And you're going to give me all the angles that have a sine value of positive square root of 2 over 2. So that would be in radians, that would be 45 pi over 4 and 3 pi over 4. Okay, the 2 means we're going to go around the circle 2 times. So I'm going to have to add 2 pi to pi over 4. So to add 2 pi to pi over 4, I'm going to need a common denominator of 4. So that would be pi over 4 plus 8 pi over 4. 8 pi over 4 is the same as 2 pi. So we're going to add 2 pi. That would give me 9 pi over 4, which is just still a 45-degree angle. It's just the second time around. And same thing, we'll take 3 pi over 4 plus 8 pi over 4, and that will give me 11 pi over 4. So that's the first time around the circle, and that's the second time around the circle. If this number were a 3 instead of a 2, if this were a 3 instead of a 2, we would go 3 times around the circle. Okay, now we're ready to solve. We would divide everything by 2, and dividing by 2 is the same as multiplying by a half. So we multiply by a half. We would get pi over 8 for theta or x, 3 pi over 8, 9 pi over 8, and 11 pi over 8. And those all lie in the interval 0 to 2 pi. So we're all, that's all in that interval. Those are all good answers. All right, here's another one. We're going to pretend that this is just x. So, but it's really 3x. But we're going to pretend for just a moment that we're finding the cosine of x equals 1/2. That 3 tells us we're going to go around the circle 3 times. All right, so what angles have a cosine of a half? That would be a 60, which is pi over 3, and 300, which is 5 pi over 3. That's one time around the circle. That's one time around the circle. So we're going to have to add 2 pi to each of those. So we've got pi over 3 plus 2 pi. We'll have to have a common denominator. So pi over 3 plus 6 pi over 3 is 2 pi. So we would get 7 pi over 3 and 5 pi over 3. 5 pi over 3 plus 6 pi over 3 gives us 11 pi over 3. That's the second time around the circle. Now we'll take 7 pi over 3 plus 6 pi over 3. That would give us 13 pi over 3. And 11 pi over 3 plus 6 pi over 3. That would give us 17 pi over 3. That's the third time around the circle. All right, now we're really trying to solve for x. So we would divide everything by 3. Dividing by 3 is the same as multiplying by 1/3. So we're going to multiply each of these angles by 1/3. That would give us pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Those all lie within the interval 0 to 2 pi. So those are all good answers. Okay, moving on. This one says solve for all possible values. That means solve for every single angle that has matches the requirement. Let me show you what I mean. Let's add sine x to both sides. Add sine x. So we're adding, so we add the coefficients. So we have 2 sine x plus the square root of 2 equals 0. Let's subtract the square root of 2. So we have 2 sine x equals negative square root of 2. Let's divide both sides by 2. So now we're down to negative square root of 2 divided by 2 equals sine x. So now what angles match this requirement? So what angles have a sine value of negative square root of 2 over 2? That would be 5 pi over 4. And I'm going to write them under each other, and I'll show you in just a second. 5 pi over 4 and 7 pi over 4. Now, when it says solve for all possible values, that means every 5 pi over 4 into infinity. So we're going to add 2 pi, and we're going to put a k after it. That means k is like 1 revolution, 2 revolutions, 3 revolutions, 4 revolutions. So 2 pi is 1 revolution. So if k is 1, you're getting the next 5 pi over 4. If k is 2, you're getting the next one after that, and so on. So long story short, when it says find all possible solutions, you're going to add 2 pi k at the end. Now, if your answers, let's just say your answers were 180 apart, like let's say we had pi over 4 and 5 pi over 4 were the two answers. Then you could take pi over 4, and instead of adding 2 pi k, you could just add pi k, and then that would give you 5 pi over 4 would be the next one. And then if k were 2, that would take you back to pi over 4. If k was 3, that would take you to 5 pi over 4. If k was 4, that would take you to pi over 4. So if they're separated by 180, you can just add pi k to your two angles. All right, next problem. So we have cotangent x times cosine squared. So my first thought is, I feel like we should rewrite this problem. One thing we don't want to do is divide by cotangent, because if you do that, that will eliminate cotangent. By eliminating a trig function when you're solving, you are eliminating possible answers. So I'm going to start by subtracting 2 cotangent x from both sides to get my cotangents on the same side. So now I have cotangent x cosine squared x minus 2 cotangent x, and we'll set everything equal to 0. Now I notice I have a binomial. I'm going to factor out the GCF, which is cotangent x. So I have cotangent x times cosine squared x minus 2 equals 0. See, now we factored. We're going to set cotangent x equal to 0 and cosine squared x minus 2 equal to 0. Set the factors equal to 0. And now we're going to solve. So this is 0 over 1. It might be easier for us to think of it as the reciprocal of cotangent, and the reciprocal of 0 over 1 is 1 over 0. So now we're answering the same thing that we would have been up here, but we're a little more familiar with tangent. So what angle or what angles are undefined? That would be pi over 2 and 3 pi over 2. Now remember, I'm going to write them below each other simply because I want to have room to add 2 pi k, add 2 pi k. Now if you notice, these two angles are 90 apart from 180 apart. So you could write it a little more concisely by saying pi over 2 plus pi k, and that would be fine as well. So you could have either these two answers together, or you could have this one answer. All right, let's solve the other part of it. Add 2, cosine squared x is equal to 2, square root, always put a plus minus when you square root. So we'd have cosine of x is equal to positive or negative square root of 2. That is not an angle, so we throw that one out. So what I have boxed in black is the only answer. And the next one, we'll add 1, divide by 3. So we'll end up with tangent squared x is equal to positive 1/3. Square root. So now we're down to tangent of x equals. Don't forget, plus minus is so important, or you skip half of your answers. We know we're not allowed to leave square roots in the bottom of a fraction, so we may as well multiply by square root of 3 over square root of 3. So we get plus minus square root of 3 over 3. So now we ask ourselves what angles have a tangent value of either positive or negative square root of 3 over 3, and those angles would be a 30, which is pi over 6, and let's see, 150, which is 5 pi over 6, and 210, which is 7 pi over 6, and 330, which is 11 pi over 6. Now, we're going to either add 2 pi to each of these, 2 pi k. We could add 2 pi k to all 4 of these, or maybe we notice that these two are 180 apart, so we could write those two by saying x equals pi over 6 plus pi k, and these two are also 180 apart, so we could write those two as such. 5 pi over 6 plus pi k. Okay, I'm going to do one more problem, and this is on the interval 0 to 2 pi, and this is a factor by grouping problem. Notice we have 1, 2, 3, 4 terms. 4 terms is always going to be your factor by grouping. I always say group the front 2, group the back 2. So factor out a GCF out of the front 2, which would be cosine x, times 2 sine x minus 1. Factor a GCF out of the back 2, which is 2, and we'd have 2 sine x minus 1 equals 0. So now we're going to bring our two GCFs together, GCF and GCF. So we have cosine x plus 2 times the common, this should always be the same. So the common binomial 2 sine x minus 1 equals 0. This is where we would set our 2 equal to 0 and solve. So we have cosine x plus 2 equals 0, and 2 sine x minus 1 equals 0. We'll come back and we'll solve. we've got cosine x equals -2. There is no angle that has a cosine